Okay, so I'm on page 3 of these 6.4 notes on properties of definite integrals. Let's see, we got a couple of different kinds of problems, and some of them are a little bit tricky. So I've got, what is the value of the integral from 0 to 3 of f of x dx? So I'm going from 0 to 3. Well, in order to do that problem, I'm just trying to find the area, right? Because they're giving me, this is a graph of f of x. It tells me right here. This is, I'm going to write that so I don't forget, this is f of x. I'm going from 0 to 3. Well, what do I have here? I'm just going to do some geometry. I've got a quarter of a circle with a radius of 2. So it's going to be a quarter of a circle pi times 2 squared. Right, that's the area of the circle. Then I'm going to have a rectangle here. It's 1 by 2 rectangle, so its area is going to be 2. And then I've got a 1 by 1 triangle, so its area is going to be 1/2. Okay, so I get 1/4 of 4 is just pi plus 2.5. And that's the answer. If I wanted to do the next one, right, I'm still looking just at the graph. Now I'm going from 0 to 4, so I'm going to have that same 1/4 pi times 2 squared, this part, this quarter of a circle. I'm going to have the same rectangle here, which has an area of 2. And then I have this triangle here, which I know is 1/2 because I already figured that out. But then I'm going to have this other triangle, because I'm going all the way to 4. I'm going to have this negative counterpart to this triangle. Well, those are going to cancel out, so that's going to be 0. So I'm going to just end up with pi plus 2. If I look at the next one, the value from -3 to 3, the integral from -3 to 3 of f of x dx, well, now I could do through, and I could go through and count all this area and everything. But what do I remember about this? Is an even function. It's symmetrical with respect to the y-axis here. That tells me that this side on the right is equal to this side on the left, which means that the whole thing is just twice this side on the right. Well, I already figured out this side on the right is pi plus 2.5. So this is going to equal 2 pi plus 5. I don't have to do any work there. Now these last problems, these are a bit tricky. So I'm going to move down here. We're going to have to kind of look back up at the graph in a second. They tell me that f of 0 is 5, and they want to find the value of f of 3, and where f is the antiderivative of f of little f. So we've got big F is the antiderivative of little f. Here's how we're going to do this problem. Well, we know that we've got f of 0 is 5, and we're looking for f of 3. So let's think about it this way. F of 3 minus f of 0, according to the fundamental theorem of calculus, is equal to the integral from 0 to 3 of little f of x dx. Now it turns out that I already found that the integral of little f of x dx from 0 to 3 is equal to pi plus 2.5. Pi plus 2.5. I know that f of 3, I don't know what f of 3 is, that's right. I don't know what big F of 3 is, but I do know that f of 0, big F of 0 is 5, because they told me that. Okay, now I've just got an algebra problem. No, f of 3 is pi plus 7.5. Just as easy as that. What you've got to do with these problems is always look at, like, what are they giving you? What x value are they giving you? And what x value are they asking you to find the value of the function at? Those two are going to be the endpoints of your interval that you're taking your integral on. Okay, so those are going to be the limits of your integral. Let's try another one over here. They'll give us f of -2 is -2. And they want us to find big F of 2. Okay, where f is the blah, blah, blah. Okay, well, let's look here. We've got f of 2. I always just write the larger x value, f of the larger x value first. It just means that you're going from right to left, from left to right when you're doing your integrals. It makes it easier. So f of 2 minus f of -2, well, by the fundamental theorem of calculus, that should equal that should equal the integral from -2 to 2 of little f of x dx. All right, well, f of 2, I don't know what that is. F of -2 is -2 equals the integral from -2 to 2. I'd have to look. I'm going to have to go back and look at my graph here. Okay, again, this is even, so I can just go from 0 to 2, right? And just double it. Well, from 0 to 2 is going to be pi, right? I know I figured out already. This is pi, and this is 2. Well, so this has to be pi. This has to be 2 as well. So the whole thing from negative 2 to 2, the area is 2 pi plus 4. So I'll go back down here. So this is equal to 2 pi plus 4. So f of 2 plus 2 equals 2 pi plus 4. F of 2 equals 2 pi plus 2. All right, that's it. That's the end of the notes on properties of definite integrals.